Hello. This is the course project for machine learning for product managers, the end of module 6 of course 1, where we were tasked to build a model to predict the net hourly electrical energy output of a power plant. So first was tasked with being given this data, as you can see on the left, and on the right's my validation and test information. Um, so first up, we were tasked with determining which machine learning approach is needed. I determined that a multiple regression approach is needed because we'll have two or more predictor variables. Here we have four. Multiple regression is the right approach because we have two or more, as I mentioned, and one outcome variable, the electrical energy output. This is favorable because the type of linear regression is best for our data set and the output as opposed to um, lasso or ridge regression. Um, Also, I used Excel. I know that a lot of people used Python, which may have been a better approach, um, but decided to go that way. And then also, in terms of which machine learning approach to use, saw that probably random forest regression will be best because of its robust high performance predictions and also reduced overfitting. We have some data here, but I know a lot of it is nonlinear, as evidence that power plant output is often influenced by multiple interacting factors. Random forest um, and multiple regression here is better because it works, as I mentioned, well with nonlinear data, is less prone to overfitting than a single decision tree, and that's why the random forest is better, and it provides feature important insights as well. Next, we were tasked with determining which possible features we may not want to use or may want to use and identify algorithms that we may want to consider. Um, in terms of this project, we were given four input variables and an output variable. Um, and I determined the features that we want to use include ambient temperature, exhaust vacuum, ambient pressure, and relative humidity. And I believe that the most important um, input variable is ambient temperature because it strongly affects the efficiency of power generation. Also, in a real world situation, higher temperatures can reduce the efficiency of the power plant and reduce energy output as well. Also, ambient temperature has the highest correlation with the output of the um, power plant. Also, exhaust vacuum and ambient pressure are good as well. Obviously, we were given those data sets and that information and those hyperparameters. Exhaust vacuum can also directly impact the efficiency of a steam turbine power plant and the energy output here. Also affects the it can have an effect on a lower exhaust vacuum and the pressure there. Also, ambient pressure affects the density of air entering the power plant. And all these factors or features will allow us to analyze the data using an algorithm. Um, we also have a tremendous amount of data to train and test with. And one possible algorithm, as I mentioned previously, would be the um, root mean squared error. So this is favorable because the square root of the mean squared error brings back the same unit as the target variable. Also, root mean squared error as opposed to mean squared error penalizes large errors, but is more efficient and brings up more information about the target variable. And it's a good balance between mean MAE and MSE as well. Um, so primary metric would be root mean squared error, as well as mean absolute error as well. So um, next, we were tasked with splitting the data to create a test set to evaluate the performance of the final model. I split the data set into about 70 to 80% of the training set to use the train model, even and train the model. And then the test set, I used 20 to 30%. So that's the good outline of how to split it. Um, so I was able to create the test set, as you can see on the right side here, and then split it from the just raw data set. So about 70% of this I used to get these averages for the output, and then evaluated the model to be able to um, use cross-validation as well to be able to perform stronger evaluation of the model as compared to fixed validation as well, which is less robust and can lead to misleading results. And then next step, using the validation approach. Like I said, I use cross-validation to compare and compared to two different models. Um, Cross-validation or k-fold cross-validation was preferable because it reduces the risk of overfitting and gives a more reliable estimate of the model performance and utilizes the large data set that we were given. A few different ones that were brought up. Like I said, um, linear or fixed validation as well, just less efficient. So use root mean squared error, like I mentioned, to be able to validate the model and be able to perform all of the equations that were required here. So use the slope that was given here after running the validation for the ambient temperature, exhaust vacuum, ambient pressure, and relative humidity. So I was able to use these coefficients or slopes to determine the actual output by using this equation here. And then finally, using the output metric of electrical energy output, I was able to correctly and efficiently evaluate the performance of my final model with a multiple regression model or the forest model, deep forest model, and then the root mean squared error algorithm to choose that and then perform the validation as well. So thank you very much.